Feel free, jump in. That's the shape of my head, yeah. Somebody once asked me if it was a brain. That scared me. I'm not sure why I'd be walking around with a brain. It's an egg. Very good. But not just any egg. This is a dinosaur egg from a haplodon. Very amazing. This curved shape was able to survive in nature without being crushed till it fossilized. And then the organics replaced with silicates, and it's almost like the first concrete. What we see here are the buildings that have held the title of the world's tallest. Starting with the Singer Building here in 1908, going to the current record holder, which is Taipei 101. But there's a new kid on the block. When I worked with Skidmore, Owings & Merrill, I had the pleasure of designing this new kid on the block, the Burj Dubai. Remember, this is Sears. Now, I do a lot of presentations to young kids to encourage them to study math, science, and of course engineering. And one 8th grader once raised his hand, obviously trying to impress his teacher. They were learning about geometry, graphing. And he says, you know, if I connect the tops of these roofs, we may have flatlined here, but it looks like we got a straight line. So in the course of 100 years, we've grown at that consistent rate, which really begs the question, where are we going to be 20 years from now or 50 years from now? And I really look to the people in this audience. If you're excited about engineering and architecture, think of the project you could be doing when you graduate from college and look at the future. Give you an idea what the view of the building looks like. It's got 24 setbacks, making it a spire pointing to the sky. And the real thing to keep in mind here, those little buildings down there are 50-story buildings. And this is not just a dream. This is going up in concrete and aluminum cladding. Where is it located? In the Middle East, United Arab Emirates, in the town of Dubai. This was Dubai, the main street, in 1990. This is the street in 2003. These 3 buildings are the same 3 buildings here. It's literally like building up the skyscraper of Chicago in just a matter of a decade. Give you an idea what the skyscraper looks like in that city. Of course, that's Burj. Burj is the center of a new development. Right adjacent to it is going to be the world's largest mall. They don't build anything in Dubai unless they predicate it with the world's largest. Make no small plans, a great Chicago phrase. Here you can see a model that they built that was 2-story tall for the building that they used for the sales event. They used this model for 3 nights. They sold 100% of the residences in 3 nights. Donald Trump's got nothing on that. I actually met Donald Trump, and you know he didn't fire me. This is an amazing structure. And in the sales center, they were so busy with sales, the guy at the front of the line who bought his units resold his units to the guy at the end of the line for 15% profit. But, you know, we can't talk about the world's tallest building unless we talk about the forces that act on buildings. And one of the key forces on a building is a wind. And we've all felt the wind push against us. But there's other types of behavior that wind happens. Wind needs to get around us, right? If we're a tall building, it's not going to go over us. We're too tall. It's not going to go under us, of course. So it has to go around us. So as the wind flows from left to right, this is in plan, the wind's got to go around one side, and then it spins off, and then it goes around the other side, creating these little vortices. You can see these vortices coming off a wing airplane here, off the roof of Hancock in this image, and even in a small test chamber. And what happens is, let's forget about the image on the screen. How many people in this room have kids or are kids? Yeah, all of us, right? Well, when my son wants to go out on a swing set, the first thing he says is, "Dad, push me all the way to the top and let me go." He calls that an underdog. Well, I do that, and I quickly discover that's a lot of work. So what do I do instead? I'll stand behind him and give him a little push in sync with his swinging. Well, each time one of these vortices come off, they give a little perpendicular to the wind direction. And the building actually will oscillate in a direction perpendicular to the wind, different than what we feel at ground level where we're dragged. It actually shakes us side to side. And that actually moves the building and controls it. Believe it or not, if a tall building were ever to fall over, it'd fall over perpendicular to the wind. But, I could talk about this all day. If a picture's worth 1,000 words, what's a movie worth? So my son built a backyard wind tunnel, and we're going to talk a bit about that in a second, but what's this a picture of? Six Flags. Roller coaster. I don't know about you, when I go on vacation, I love roller coasters. We hunt down every one we can find. But would I want to sleep on one? I'm kind of happy sometimes when that ride's over in 2 minutes. Well, when this building's shaking up in the sky, do you want to be sleeping on a roller coaster? So a lot of the job of the engineer and the architect is to maintain those motions so that they're acceptable to human motions, and they're fine. So here's the backyard wind tunnel we built. My neighbors don't like me. But you can see the building shakes when the fan blows, and the tree blows, but that's a different thing. Now, one way to stop the building shaking is to have a giant hand. But other things we can do is we can add mass to the building, like make it concrete, make it stiff. But we can also add dampers on the top of the building, like dampers in your car. In this case, we're filling a sloshing damper with magic fluid, otherwise known as water with green food coloring, and a little item for the water to flow around, known as my son's Lego. But now that little tank of water on the top, no computers, no power source, are resisting those motions we just saw a second ago by splashing in exactly the right shape. Again, there you see the little Lego. So this little tank of water without a computer is stopping the motions of the building. Think about that. Think of the creativity you can do. And now to show it's not a trick, it's all about the shape of that tank. I can rotate it 90 degrees, let go, and now that sinusoidal oscillation develops back again. I don't know about you, I get seasick watching this. What are other forces we have on the things? Well, we also have earthquakes, in addition to wind. And, we always see these big horror movies about earthquakes and the super tall buildings, right? Well, actually, super tall buildings are fairly safe in earthquakes. They're able to ride out the motions of the earthquake kind of like a tall blade of grass, and they can flex with the structure. And they can absorb the energy through cracking of the concrete, which is a good behavior. Because we saw cracking with reinforcement does not fail. And to show that that works, in addition to a backyard wind tunnel, we have our own earthquake shake table here. It's going to be operated by my son Alex. What we have here is, in the back, a super tall high-rise. And in the foreground, a somewhat interesting architecture low-rise building. My son engineered, so to speak, the two of those. Can you start the earthquake a little bit for us? Now we're at a very low Richter scale earthquake, very moderate. But he has the controls to be able to ramp that up a little bit for us. I think we can start to see the tall building oscillate. Oh, I think it fell today. Take it all the way up. Usually it just flexes. And, we got the low rise flexing. Yay. If he's nice during this, he'll rebuild the tall one and see if we can get it to survive the earthquake. It usually does. Like I said, you discover everything new when you try demos. I suspect we hit it a little bit when we were moving it from the back so quickly. But using all that technology, we're able to build very, very tall. This is the Burj Dubai up at the top of the formwork.